The moon has always been a symbol of silence, a dead quiet world where nothing changes. But that silence is a lie. On December 12th, 2025, that illusion was shattered in real time. A Ph.D. student named Andrew Marshall Lee was sitting in the control room of the Armagh Observatory in Northern Ireland, doing what astronomers have done for centuries, watching the night sky. He wasn't expecting history, he wasn't expecting violence, he was just monitoring the data streams. And then it happened. A flash, a sharp, brilliant burst of light on the lunar surface. It lasted only a fraction of a second, but it changed everything we thought we knew about the safety of our celestial neighbor. This wasn't a glitch. It wasn't a satellite reflection. It was a direct hit. A piece of space debris, roughly the size of a golf ball, had just slammed into the moon at a velocity so high that the impact released the energy of an explosion. Most of us think of space rocks as these massive, extinction-level asteroids that we can track years in advance. But the real danger, the one that keeps space agencies up at night, isn't always the mountain-sized rock. It's the invisible bullet, the golf ball moving at 30,000 miles per hour. What Andrew captured that night was incredibly rare. Not the impact itself, those happen all the time, but the fact that a human being saw it happen live. It was the first time such an event had ever been recorded in Ireland, and only the second time in the history of the United Kingdom. So why does a tiny flash on a grainy monitor matter? Because we are about to put humans back on the moon to stay, and that flash is a warning shot. To understand the gravity of this event, we have to look at the physics of the kill. How does a rock the size of a golf ball create a flash bright enough to be seen from Earth, nearly 240,000 miles away? It comes down to speed. On Earth, if you throw a golf ball, it bounces. In space, objects don't throw. They travel at orbital velocities. When that rock hit the lunar regolith, it wasn't pushing dirt around. It was moving so fast that upon contact, its kinetic energy was instantly converted into heat and light. It vaporized itself, and the rocket hit, creating a miniature explosion. That flash is thermal radiation. Heat so intense, it glows white hot in the vacuum of space. And here is the terrifying part. The moon has no shield. Earth is wrapped in a thick blanket of nitrogen and oxygen. When a space rock hits our atmosphere, the friction incinerates it. We see a shooting star, a beautiful, harmless streak of light. The atmosphere takes the hit for us. But the moon is naked. There is no air to slow anything down, no friction to burn it up. Every single grain of sand, every pebble, every golf ball-sized rock strikes the surface with 100% of its velocity. Andrew Marshall Lee wasn't just watching a rock hit the ground. He was watching the raw, unfiltered violence of the cosmos. But where did this bullet come from? Forensic astronomy gives us a likely suspect. The timing of the impact on December 12th coincides perfectly with the peak of the Geminid meteor shower. If you've ever gone stargazing in mid-December, you know the Geminids. They are one of the most reliable and spectacular light shows of the year. But while we enjoy the fireworks safely from beneath our atmospheric shield, the moon is getting pummeled. The Geminids are strange. Most meteor showers come from comets, dirty snowballs that melt as they get close to the sun, leaving a trail of dust. But the Geminids are different. They come from an object known as 3200 Phaethon. Phaethon is an enigma. It looks like an asteroid. It's made of rock, not ice, but it acts like a comet. It has a weird, eccentric orbit that brings it scorchingly close to the sun, causing it to crack and fizzle, shedding tons of rocky debris into space. This rock comet leaves a river of rubble in its wake. Every December, Earth and the moon plow right through that river. For us, it's a light show. For the moon, it's a minefield. Scientists estimate that tens of thousands of impacts happen on the moon every single year. Most are too small to see from Earth. They are microscopic grains hitting the surface like cosmic buckshot. But the one Andrew saw was different. It was large enough to be a killer. This brings us to the so what factor. Why are scientists and engineers obsessing over this one recording from Northern Ireland? It's because of where we are going. We are currently in the middle of a new space race. The Artemis program, the concept of the moon village, the push from private space companies. Everyone is targeting the lunar South Pole. The plan isn't just to visit. The plan is to build habitats, landing pads, solar arrays, oxygen extraction plants. We are talking about delicate, high-tech infrastructure and soft, fleshy human beings living on the surface for months at a time. Imagine you are an astronaut sleeping in a lunar habitat. You have walls, you have shielding, but if a golf ball-sized rock hits your base at 20 kilometers per second, it doesn't just poke a hole, it explodes with the force of a grenade. If we don't understand the frequency of these impacts, we can't design the armor. We need to know, how often does a rock of this size hit a specific square kilometer? Is it once every 100 years or once every 100 days? That is why Andrew's discovery is scientific gold. By capturing the flash and measuring its brightness, astronomers can calculate the mass and speed of the object. They can say, okay, during the Geminids, the risk level spikes by 500%. That data informs mission control. It might mean that during the Geminid shower, astronauts are ordered to stay in underground bunkers or heavily shielded rovers. It might dictate how thick the walls of our future lunar homes need to be. This creates a paradox of exploration. The moon is the perfect stepping stone to the rest of the solar system, specifically because it has no atmosphere. It's easy to launch rockets from there, but that same lack of atmosphere makes it a shooting gallery. The impact captured at Armagh Observatory is a reminder that space is not empty. It is active, it is crowded, and it is fast. The solar system is filled with the debris of creation, billions of leftover bricks from the time the planets were formed. We are constantly navigating through this wreckage. Andrew Marshall Lee was monitoring the moon to help us understand these risks. Most of the time, this work is tedious. It's algorithms scanning darkness. But every now and then, the universe blinks back. This event also highlights a crucial gap in our technology. Right now, we mostly rely on luck to see these things live. We don't have a 24/7 high-definition surveillance network covering every inch of the lunar surface. We miss most of the impacts. If a base had been at that specific location on December 12th, 2025, and we hadn't been watching, we might never have known what hit it. We might have just lost contact. As we move forward, we're going to need more eyes on the sky. We need automated systems, better telescopes, and more dedicated researchers like the team in Northern Ireland. We need to map the debris streams of objects like 3,200 Phaethon with the same precision that we map hurricanes on Earth. The flash on the screen was fleeting. It was there and then it was gone. But the lesson it left behind is permanent. As we prepare to leave our footprints on the moon once again, we have to respect the environment we are entering. It is beautiful, yes, but it is also a place where a pebble can strike with the power of a bomb. The work being done at observatories right now isn't just academic. It's the reconnaissance work for the next great human migration. Every flash recorded is a data point that could save an astronaut's life 10 years from now. It's not just about looking up, it's about looking out for our future. So the next time you look at the moon, don't just see a static, glowing orb. Remember that it's taking the hits for us. Remember the invisible river of rocks from the asteroid Phaethon. And remember that somewhere in a dark control room, a student might be watching a monitor right now, waiting for the next flash that tells us a little bit more about our place in the stars. If you want to stay ahead of the curve on space exploration and the mysteries of the cosmos, make sure you're subscribed. We are tracking the future of humanity among the stars, one impact at a time. Thanks for watching.